Hi everyone, my name is Jonathan. Today, along with my colleagues Hazik and Farhan, we will be discussing on heat recovery steam generator (HRSG) system. In our discussion, we will elaborate on what is a HRSG system, the classifications of a HRSG system, as in the types that are available in the market, the process flow of a HRSG system from the start of its process right up to the end of its process. We'll also be covering on the individual components that makes up a HRSG system. Last but not least, before concluding our discussion, we will be comparing HRSG system with a conventional boiler. What is a heat recovery steam generator? It plays a role as a heat exchanger that recovers energy, specifically removes heat from hot gas steam, such as combustion turbine or other waste gas. HRSG parts consist of components such as economizer. An economizer is a heat exchanger designed to exchange heat with fluid, mainly water. It is commonly incorporated in a boiler to provide sensible heat to water. This is to prevent heat loss and reduce load on the boiler. HRSG also comprises of an evaporator. An evaporator consists of water flowing tubes. Feed water that flows through the tube enters into a steam drum where it is evaporated into wet saturated steam. Last but not least, it consists also of a superheater. From evaporators, this wet saturated steam enters into superheater where it is converted to dry steam. This is because steam turbine runs on dry steam. Steam generated is used for cogeneration mode or combined cycle operation in CHP. Cogeneration is a simultaneous production of both heat and electricity. Classification of heat recovery steam generator. In installation of a HRSG system, it consists of two types of orientation, which are vertical HRSG and horizontal HRSG. A vertical HRSG has a vertical flowing gas and a horizontally placed coil. The gas flows across the coils. And as for horizontal HRSG, it is vice versa. Horizontal design HRSG requires a large footprint. It is more difficult in maintenance and inspection. The design of circulation in HRSG is highly dependent on its orientation, which determines the space availability. Another type of classification of HRSG would be natural circulation HRSG. A natural circulation HRSG does not require a pump, hence less energy consumption. It is easy in operation and maintenance. It has high stability due to low center of gravity in installation. Consists of a large regenerative capacity which is capable to adapt load and pipeline of heating surface of vertical layout. Last but not least, a forced circulation. A forced circulation requires a pump in operation. This pump hence increases power consumption. A forced circulation has a smaller footprint and its compact structure based on small pipeline diameters. The small volume of water of a forced circulation that is produced increases its tendency to increase the temperature. That's all from me. My colleague Amirul will further elaborate on the process flow of a HRSG system from start right up to the end.
Hi, I'm Amirul. So for my part, I will explain on heat recovery steam generator schematic diagram and flow, and also a brief explanation on superheater and evaporator. So in this diagram, we can see that this is a heat recovery steam generator. How it functions is the exhaust gas from gas turbine will flow into the superheated tube, and heat from the gas is used inside the superheated tube to produce the superheated steam. Next, we have evaporator. The evaporator will produce saturated steam which flow through the superheated tubes. And then we have economizer. Economizer. Moving on, now we have superheater, which is one of the components in heat recovery steam generator. It functions to raise the temperature of saturated steam to become superheated steam. The superheated steam is used for the application of steam turbine in combined heat plant. When we use superheated steam to perform work by way of expansion in the turbine or steam engine, it will not condense and it will reduce the damage to turbine or steam engine. And the dry saturated steam is used because water droplets can cause damage and degradation to the turbine blade after a long period of usage. Next, we have evaporator, which is the second component in HRSG. It functions to convert water into saturated steam. It has two types, which is natural circulation or forced circulation. The evaporator pipes in steam boiler are usually located on the floor and on the wall. In this pipe, quality of saturated steam are at 0.8 to 0.98, so it is still in liquid phase. The evaporator will then heat the water that fall from the drum, which is in liquid phase, to form saturated steam, so it can be forwarded to superheater.
Economizer is one of the heat recovery steam generator components that consists of water pipes that are placed on track of flue gases after evaporator's pipe. The function of economizer is to heat the feed water before it enters the steam drum and evaporator. This evaporation process can be easier by using high temperature of flue gases from the heat recovery steam generator, so it increases the efficiency of the heat recovery steam generator and reduces the heat loss. Water which enters evaporator from after passes through the economizer is at high temperature. This can benefit the pipes which will not be easily damaged due to the differences in temperature. There are differences between HRSG and conventional boiler. First, HRSG is only a heat transfer area. There is no furnace, even though the section is like economizer, evaporator, superheater are present. This is exception for supplementary fired HRSG. Second, in conventional boiler, the evaporation and superheating takes place in a single pressure level. For HRSG, there are multiple pressure formats which prove the efficiency of SRSG. Lastly, the output of the SRSG is solely dependent on the performance and load of the gas turbine. The steam temperature control is limited to the use of the superheater. To conclude this presentation, we have explained to you what is a heat recovery steam generator and types of heat recovery steam generator available. The components of heat recovery steam generator such as superheater, evaporator, and economizer are explained, and the differences between a HRSG and a conventional boiler is elaborated. To conclude, whether used for district application process heating or electricity production, SRSG has offered value for money for its owner. It offers economic and environmental benefits where it utilizes the waste energy from other operations in a combined heat plant to generate a beneficial energy which can be used. That's all from us. Thank you.